So you have your transformations foldable out, yes? When we talk about things being added or subtracted to a function, either outside or inside, what kind of change does that cause to the function? A shift, right? That causes a shift. And just on a silly side note, what's the most important part of this word? The F. Wait, we have to remember our F's, okay? Whether it's inside or outside depends on whether it goes up or down, left or right. Remember that, okay? What does a negative sign cause? A reflection, right? Depending on where it is, inside or outside, will determine whether it's over x-axis or y-axis. But a negative sign causes a reflection, okay? And then we have multipliers. What kind of change does a multiplier cause? A stretch or a shrink. Again, depending on whether it's inside or outside of the function, will depend on whether it's a vertical shrink or horizontal shrink or stretch, right? Okay? So you have this at your disposal. You can absolutely use this, can't you? Okay? So now I need to talk specifically about the kind of parent function that we're talking about today. Between these, excuse me, between these two examples right here, which one of these is an exponential function? Which one is an exponential function? Why is it the first one? What's this? It's a quadratic, right? Now, why would people argue that this is an exponential function? Because it has an exponent, right? But what makes an exponential function? God bless you. What makes something an exponential function? Where is the variable? In the exponent. The variable is in the exponent. Okay? This variable is just a 2. We've already studied that one this year, haven't we? When the variable is in the exponent, that is an exponential function. So when we have something added or subtracted to that function, 2 to the x, what's going to make a horizontal shift? What's going to make a horizontal shift? Well, if it's inside the function, right? If we're talking about inside an exponential function, what are we talking about being inside of? Inside of what? The exponent, yeah. So if I want to move this to the right 4, what do I have to add inside the exponent? Minus 4. Remember, if it's horizontal, it's backwards of what we think, right? So the x minus 4 is the exponent. X minus 4 is the exponent. And we know that causes a horizontal shift to the right 4, right? Does that make sense? Here, I'll write that. Horizontal shift right 4. What's going to move it to the left 5? Where? A plus 5 in the exponent. That's going to cause a horizontal shift left 5. You okay with that? So what's going to cause it to move down 3? Would it be in the exponent anymore? Or would it be outside the exponent? Outside the exponent. So what did I say, down 3? So it's just minus 3. The 3 is the same size as the 2. It's 2 to the x, then minus 3. So this is going to be a vertical shift. Down 3. So what's going to cause it to move? Up 7. Plus 7 where? On the outside, right? So plus 7. So vertical shift 7. Now, is any of this new? What's the new part? The actual parent function, right? The actual, and the parent function we're using is 2 to the x. Now, exponential functions are weird. They're different based on the other functions that we've talked about before, because other parent functions that we've talked about, like y equals x squared, that's the only parent functions for quadratics, isn't it? Okay? But a parent function for exponential could be y equals 3 to the x. That's a parent function. Y equals 4 to the x. Y equals 1/2 to the x. Those are all parent functions. It's just that whatever the base is, that's the only thing that's there. There's nothing being added, subtracted, or multiplied to that base. Does that make sense? Okay? So just be careful of that. Because if I give you this equation right here and say, how does it change compared to its parent? Sometimes people will say that it moves up 7, but sometimes they're like, yeah, but I don't know what the 2 does to it. The 2 doesn't really do anything to it. The 2 is the parent. Does that make sense? It's where this function started. Does that make sense? Okay. So what about this then? Y equals negative 2 to the x. What's the negative cause? A reflection. Now this negative is on the outside of the parent, so that causes a, what kind of change? Vertical change, right? So what is it reflecting across? What would make it reflect over the y-axis? If the negative was inside. Very good. Okay? And then, do I need to write that one down for you? You got that one. Yes? Okay. So y equals 2 to the negative x. And that causes a one half times 2 to the x. Yes. What kind? Is it inside or outside? Is it multiplied? Is it on the inside of the exponent or on the outside? So that causes a vertical change. And you said this is a vertical shrink. How did you know it was a vertical shrink and not a vertical stretch? Because it's between 0 and 1, right? Now what about the 2? What did I tell you a minute ago that the 2 did? It's just the parent, right? It gives it its original shape. So it's everything that's changed compared to the 2, right? Okay? What if instead of a 2 or 1/2 right here, this was like a 7? That would be a vertical stretch, right? If this 1/2 was a 7, it would be a vertical stretch by a factor of 7. Okay? Now, here's something I have to stop right now. Like, I want to stop this right now on the very first day that we talk about exponential functions. Okay? Because you know what some people want to do right here? Multiply them. Why can we not multiply these two things right here? One of them has an exponent. Order of operations says I have to do what first? I have to do exponents before multiplication. Can I do anything with this exponent? No, it's a variable. So if I can't do anything with this exponent, I cannot multiply these right now. Maybe if I have a value for x that I can plug in, then I would do the exponent, then I would multiply. But I don't want you to get used to multiplying these two things right now. At all. At all, at all, at all. Okay? Because what it's telling us is, first of all, I don't want to multiply them because this is telling me what kind of change that I have compared to the parent. If I go ahead and multiply them, there's nothing. Right? So don't, please, 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 don't multiply these two things together. You can't while there's an exponent that we still don't know anything about. Okay? Does everybody understand? Okay. Now, this whole time we've been using this, 2 to the x, right? This whole time we've been using that as our parent function, right? Now you know that looks like this, like a quick sketch that looks like that, because that is called exponential growth. Good. But you know there's a different kind, right? There's another exponential function. And that exponential function looks like this, when the base is between 0 and 1. Like we talked about the multiplier just a second ago, right? This multiplier is between 0 and 1, because so that causes a shrink. If the base is between 0 and 1, what does that cause? It causes a change in name, first of all, right? Yep. And it looks like this. So this is growth, this is decay. Now, I have a trick question for you. Are you ready for a trick question? Okay. I'm going to scoot it up just a little bit so you can still see both of these graphs, but I got to draw a graph for you. This graph right here, is that growth or decay? Why do you think it's growth?
Because it's going in the direction, but it's just flipped upside down.
It is, right? It would be going this way, but it's reflected this way. If it was not reflected, wouldn't it be like this? So that would look something like maybe negative 2 to the x, right? Negative 2 to the x is still growth because that base is still a 2. But it's falling, so you think it should be decay, except it's not falling in the right pattern. Does that make sense? Okay? So I need you to keep that in mind when you start your homework today. Where is your homework? On IXL. Okay? When you open up IXL, here's what you're going to see. Not exactly because I'm drawing it myself. Okay? But it will be something similar to this. And there'll be boxes, either above or below. I don't remember where the boxes are. Above or below the problems. And then either above all of them or below all of them. I think it's above all of them. It'll say something like this. And you have to match. You have to click on this and drag it to one of these boxes where it goes. Where is this one going to go? Of these 4 graphs, where is it going to go? Because it's growth and it's right here at 1, isn't it? So isn't that going to be y equals 2 to the x? Okay. What about the second one or third one or fourth one? What goes where? So do you think this one right here goes down here?
Yeah.
So y equals 1/3 x. Whoops. To the x, right? So we did that one and we did that one. What about these two? How are you matching them? Tell me your thought process. Is this growth or decay? Is this growth or decay? Decay. So which one of these is growth and which one is decay?
Growth is on top.
Growth is here, decay is here. So these two are both growth. So I know These two have to be this graph. Do you see what I'm saying? Do you see what kind of thought process you need to have to do these kind of problems? And then once you match them all, then you hit submit, and it tells you if you're right or wrong. Your SMART score is going to be your grade. Yes? Okay? Now, if this is what you see on the paper, let's see, y equals, what do we say this was? 2 to the x minus 5, and then y equals 1/3 to the x minus 5. What are you required to write down on your work? Because you know you have to write work, right? So I challenged last period. What do you think is the best way to write this down? What's the easiest? What is the helps you the best way to write it down? Here's what they did. Okay, they went and listed the equations first. So y equals 2 to the x, y equals 1/3 to the x, y equals 2 to the x minus 5, y equals 1/3 to the x minus 5. And then they sketched the graphs. Is it giant? Does it take a lot of room? Could you do this where it took a lot of room? Yes, right? I'm not asking for a lot of room. I'm asking you to show your work. Show your thought process. Write your answers. That's what I'm asking for. Does everybody understand that? Okay. Do you have any questions about what is expected of you on this assignment? You good? Can you use this foldable on your assignment? 100% yes. Correct? Any other questions? Any other questions?